is sharing a very common and critical issue in modern 3D animation. Right now, many animators are creating 3D animation, but the character often looks stiff and unnatural. One major problem with 3D animation is unrealistic muscle movement. The position of the jaw is precisely defined, but there is no sense of muscular weight. If an animator only uses standard joint, the muscle remains flat and disproportionate.
Another critical issue is character movements. That's completely defied as dead laws of physics, especially regarding secondary elements like clothing and hair. Currently, hand clothing are controlled using basic skeletal bone without dynamic physics systems. As a result, when a character runs or turns, the hair and clothing look entirely weightless and gross unnaturally.
To solve this problem, we introduce machine learning physics simulation. Our solution works by using AI to generate realistic muscle motion and automatically simulate clothing movement in direct response to gravity and character velocity.
Let's look at how this technology works. First, devise a specialized loss function to enforce real-world physics constraints, such as gravity, momentum, and body conditions. Next, run high-fidelity transition physics simulation across millions of frames.
Then feed these simulated frames into the machine learning system as comprehensive training data. Finally, let the AI model predict complex soft body and cloth dynamic in real time. In terms of feature, this software features an AI engine that analyzes movement in real time. It functions as a dynamic simulator for soft body physics, clothes dynamic, and hair behavior.
The key benefits of these systems is that it delivers anatomically accurate weight, elasticity, and natural jiggle for skin, fat, and muscle layer without needing manual frame-by-frame adjustment. What makes this solution so valuable is that clothing and hair react naturally to light, direction change, and fast movement without any stiffness, clipping, or unwanted jittering.
For example, when a character lands heavily on the ground, the AI automatically calculates the mass and impact the thigh and chest with realistic jiggle and deformation. Or when the character spins around rapidly, the heavy coat and long hair respond dynamically to centrifugal force and sway naturally before settling.
Machine learning physics simulation solve the problem of unrealistic movement. If studios adopt this AI technology, audience will enjoy a highly realistic and fascinating viewing experience.